Okay, so this is page 2 of our notes, and now we're going to look at the word cosine and think about what it means. What cosine means is it means the complement's sine. And if you go back and remember, whenever you have a right triangle, you've got a right angle and then you've got two other angles, which are always complementary because they have to add up to 90 because the angles inside a triangle add up to 180 and there's 90 right there. So there's got to be 90 more in those two angles. So they always add up to 90, so they are always complementary to each other. B is the complement of A is the complement of B. So when I find the cosine of A in this triangle, cosine is adjacent over hypotenuse, so it's B over C. And what that means is the complement's sine. So if I take the sine of B, look at B, opposite over hypotenuse is its sine, which is B over C. So these two things are the same because cosine A means the complement, the sine of A's complement, and A's complement is B, so its sine is B over C. So this means the complement's sine. So that's where the word comes from. All right, then we've got a problem here where we've got an isosceles triangle and we want to find the lengths of all of its altitudes. Now an altitude is just when you drop a perpendicular down from one of the vertices to a base, depending on how you orient the triangle. So if I drop this altitude down to this base and I want to find the length of that, I can do that easily because this is an isosceles triangle. And so I know when I drop an altitude, it splits the base in half, and this tells me that the base here is 6. So that means that each of these little pieces is 3. And so I could just use the Pythagorean theorem on this little triangle, this little right triangle here, to find x. That'll work on this particular altitude. But if I turn the triangle and I decide that I'm going to drop an altitude down from B down to side AC, and I want to drop that down perpendicular to that base, I can't use the Pythagorean theorem there because I only know one side and I don't know anything but that this is a right angle. All right, so it won't help me in that case. In that case, I would need to know some of the angles of this triangle. So what I'm going to do in order to make sure I can find all the altitudes is I'm going to go ahead and find out what these angles are. I'll find out what angle A is. So let me just erase that other altitude for a minute because it's confusing. And let's just use what we know to figure out what angle A is. All right, so if I look at this right triangle here on the left side, I do know that this is 3, so one of the legs is 3, and I do know that the hypotenuse is 8. And if I want to find the angle here, angle A, I can use cosine, inverse cosine actually, to find out what that angle measure is because I've got the adjacent side to A, which is 3, and I've got the hypotenuse, which is 8. So I can say cosine of A is equal to adjacent over hypotenuse, so 3/8. And then I can use my calculator to find out what A is because I'm looking for the angle whose cosine is 3/8. So I hit 3 divided by 8 equals, and then I'm going to take the inverse cosine because I don't have the angle. I can't take the cosine of the angle. I don't know what the angle is. I'm looking to find out which angle has that cosine. So I hit inverse cosine. And that gives me A being about 68 degrees. So A is about 68 degrees. And if A is 68 degrees, then since this is an isosceles triangle, B would also be 68 degrees, about. And therefore those two angles, the bottom two angles, add up to 136, which means that the angle on top, C, is going to have to be 44 degrees for it to all add up to 180. So C is about 44. All right, so I've got all the angles. I don't really need the angles in order to find this particular altitude because, like I said, I know the leg and I know I have hypotenuse, so I can just use the Pythagorean theorem. So to find this altitude, this one, I can just say 3 squared plus x squared equals 8 squared. And so 9 plus x squared equals 64. So x squared equals 55. So x is the square root of 55. So that altitude I've got. Now, let's turn it on its side and let's see if we can find this altitude, the one that goes down from B perpendicular to AC. So I'm making this right triangle now right here. All right, and I know that the hypotenuse of that right triangle is 6, and I'm looking for this side, so I'll call that H. And I know that angle A, I found out just a minute ago that angle A is about 68 degrees. All right, so if I want to find this altitude, I can use that angle, and I can use the fact that 6 is the hypotenuse of this right triangle. And I can say, all right, well, I've got angle 68. I'm looking for opposite, and I've got hypotenuse. So I'm going to use sine. So I can say sine 68 equals h over 6, and then I'll be able to find out what that altitude is. All right, so let's set it up. Sine 68 is equal to opposite, which is h, over hypotenuse, which is 6. So if we multiply both sides by 6, we'll get that altitude, 68 sine times 6, and that's going to give me h is about 5.56. So that altitude right there is about 5.56. Now, if I go find the other altitude, the one that goes down from A down to side CB, it actually turns out to be the exact same length as this one. Because it's an isosceles triangle, it looks the same whether you turn it on that side or that side. So there's 2 altitudes that have this measurement, and there's 1 altitude